IL 34th January 2018, question number 6. The curve shown in this figure 2 has equation y square is equal to this curve 310x over 2, x is from 0 to pi and y is greater than 0. The finite region R is bounded by the curve x is equal to pi over 3 and x is equal to pi over 2. We have to find the volume of the solid generated by the revolution of this area. So we know the volume is pi a to b fx dx. So the volume will be a is pi over 3 and this is pi over 2, pi here. Fx is 310 x over 2 dx. So y is equal to pi. If we integrate it, it will be minus that is ln, not cos, that is this is 3 and this integral is minus ln cos x over 2 divided by 1 over 2, pi over 3 to pi over 2. So we can write here v is equal to pi, this will become 6, this is minus 6 ln cos x over 2, the mod of x over 2, pi over 3 up pi over 2 to pi over 3. So that is equal to pi minus 6. So we are having ln mod cos x is pi over 2. So this is pi over 2 multiply 2 minus ln cos minus ln modulus cos 1 over 2 and pi over 3. So this will be equal to pi minus 6 ln cos pi over 4 plus 6 ln cos pi over 6. So this is equal to pi. Let's write this value 6 ln cos pi over 6 is 1 over root 2 minus 6 ln pi over 6 is root 3 over 2. 3 over 2, and this one is 1 over root 2. So that's equal to pi. Let's take 6 common. Ln root 3 over 2 over 1 over root 2. We have used log a minus log b. So that is equal to 6 pi ln root 3 over 2 multiply root 2 over 1. So it's equal to 6 pi ln this root 2 and 2. So it can be written as root 3 over 2. But we have to prove that v is equal to a ln 3 over 2. This is, we have root 3 over 2. If we get the square of it, so let's write 6 pi as 3 pi multiplied 2 ln root 3 over 2. So this will be equal to 3 pi. This 2 will become the power a log m is equal to log m to the power n, m to the power a. So this will become ln root 3 over root 2 is to the power 2. So that is 3 pi ln root 3 square is 3 over 2. So this is the volume, and that is what we were supposed to prove, that v is equal to a ln 3 is to the power 2. So a is equal to, we can say that a is equal to 3 pi. So where a is 3 pi. The question says a is a constant to be found, so this is a constant. Question number 7, with respect to the fixed origin O, the lines L1 and L2 are given with the equation. So we can write this as 13, 15 minus 8 plus lambda 3, 3 and minus 4, 3, 3 and minus 4. Show that they meet, so they are going to be equal to the point of intersection. So that will be 7 minus 6, 14 plus mu 2 minus 3, 2, 2 minus 3 and 2. So the equations will be 13 plus 3 lambda is equal to 7 plus 2 mu, and 15 plus 3 lambda will be equal to minus 6 minus 3 mu, and minus 8 minus 4 lambda will be equal to 14 plus 2 mu. Let's try to solve this equation 1 and equation 2. So 13 plus 3 lambda is equal to 7 plus 2 mu, and this is 15 plus 3 lambda is equal to minus 6 minus 3 mu. The coefficient of lambda is constant, so we subtract. We change all the signs. So 13 minus 15 is minus 2. This is cancel. Will be equal to 7 plus 6 is 13 plus 5 mu. So 5 mu is equal to minus 15 and mu is equal to minus 3. So that is the first value we have got, that the value of mu is 3. Now we can put this in the equation number. So we put this value, put mu is equal to minus 3 in 13 plus 3 lambda is equal to 7 plus 2 mu. So that will be 13 plus 3 lambda is equal to 7. Mu is negative 3, so 7 minus 6, that is 1. So 3 lambda is equal to minus 12. So lambda will be minus 4. So lambda, not mu, the lambda is equal to, lambda will be minus 4. Lambda is equal to minus 4. We have got these two values from equation 1 and 2. Now let's put mu and lambda in equation 3. So that is our third equation. That is minus 8 minus 4 lambda is equal to 14 plus 2 mu. Minus 8 minus 4 lambda, that is 16, plus 16 is equal to 14 and mu is 3 minus 6. This is 8 and 14 minus 6 is also 8. So this is true. So it shows that the L1 and L2 intersects. So the position vector of point of intersection we have to find the position vector of point of the intersection. So we are going to put these values of mu and lambda. So it was 13, 15 and minus 8. Then the value of lambda is was minus 4, and that was 3, 3 and minus 4. 3, 3 and minus 4. So this is equal to 13 minus 12, 15 minus 12 and minus 8 plus 16. So that is equal to 1, 3 and 8. So this is L1, this is L2, and this one is the position vector of point B. They are intersecting at B. So that is the answer of first part A. Now we have to find the angle between the lines. So for the angle we can write cos theta is equal to, that is 3 minus 4 and 2 minus 3 2 divided by root 3 square plus 3 square plus minus 4 square multiply root 2 square plus minus 3 square plus 2 square. So cos theta will be, if you are going to solve it, this is you can use a calculator and you solve it, it will be negative 11 over 17 root 2. So theta will be cos inverse negative 11 over 17 root 2. So theta is going to be 62.8 degree. If you want to write in a radian, it will be 1.1. You can write the answer like that. C part is, there is a point A whose position vector is minus 5 I minus 3j plus 16k. So we have to prove that A lies on L1. So let's get the position vector of the first line is, that was our 13, 15 minus 8 plus lambda 3 minus 4, 3 minus 4. So if this is A lie on it, so it must be equal to minus 5 minus 3 and 16. So let's try to solve it. So 13 plus 3 lambda is equal to minus 5. 3 lambda is equal to minus 18. So lambda is equal to minus 6. So so this is a proof that if lambda is minus 6, it lies on the line. Part D is, there is another point C which lies on L1, and the given condition that the vector AB is equal to vector BC. So we have to find the position vector of C. So first try to find out the AB. So AB will be, so the line L1 is 13, 15 and minus 8. 13, 15 and minus 8, and lambda plus lambda 3 and minus 4. We can easily conclude that at C lambda is equal to minus 2. So 3, 13, 15 minus 8 minus 2, that is 3 minus 4. So that will be equal to 13 minus 6 is 7. 15 minus 6 is 9. And 8 minus 8 plus 8 is 0. So the position vector will be 7i plus 9j. That will be the position vector of C, which is lying on line L1. The question number 8 is y is equal to 8 tan 2x, and we have to find dy over dx. So we know that if y is equal to 10x, then dy over dx is equal to sec square x. So we are going to use this. So y is equal to 8 tan 2x. So dy over dx is 8 sec square 2x multiplied by 2. So it will be 16 sec square 2x. Now we have to write it in this form of a over b plus y square. Now how to convert it into this form? So let's simplify this. We can write it as 8, that is 16, not 8. So we have now dy over dx is 16 sec square x is equal to 1 plus tan square x. So 1 plus, we can write it at 1 plus tan square 2x. So we can see in this equation there is no 10, so there is y. So how we can convert it into y? So tan square 2x, let's say y over 8 is equal to tan 2x. If we square both sides, so tan square 2x is a y square over 8, yes. So that is equal to 16 1 plus y square over 64. So it's making some sense. So that is 16 plus 16 y square over 64. So that will be equal to 16 plus y square over 4. Can be written as 4, that is 64 plus y square. Dy over dx is 16. So, but what we have to prove is that is over y squares. Okay, we have to prove dx over dy. So dx over dy, the reciprocal, 4 over 64 plus y square. And what we are supposed to prove, that it is a over b plus y square. So a is equal to 4 and b is equal to 64. So that is the answer. Question number 9, part A. Show that cot square x divided by 1 plus cot square x is equal to cos square x. We can convert it into, let's convert it to sine and cos. So we have cot square x will be equal to cos square x over sine square x. This will be 1 plus cos square x over sine square x. So this will be equal to, that is cos square x over sine square x multiply this, so this will be sine square x plus cos square x divided by sine square x, so it will be sine square x. So sine square x and sine square x cancel, and sine square x plus cos square x is equal to 1. So it will be, so this is the left hand side is equal to right hand side, that is the cos square x. Part B is, hence solve for x from 360 to 0, and that is cot square x over 1 plus cot square x is equal to 8 cos 2x plus 2 cos x. We have just proved that cot square x over 1 plus cot square x, this one is cos square x, is equal to 8 cos 2x plus 2 cos x. Now this is a double angle, this is single and the single, so we know that cos 2x is equal to 2 cos square x minus 1. So let's put this value here. So cos square x is equal to 8, cos 2x is 2 cos square x minus 1 plus 2 cos x. So cos square x is equal to 16 cos square x minus 8 plus 2 cos x. Let it come this side, so it will become 15 cos square x plus 2 cos x minus 8 is equal to 0. Now this is a quadratic equation of the form 15 x square plus 2x minus 8 is equal to 0. So we have to solve it. So 15 multiply 8, 15 multiply 8, that is 3 multiply 5 and say 4 multiply 2. So the differences vary, so we take bigger and a smaller number. 5 times 2 is 10 and 4 is 12. So 2 can be written as, so we can write this as 15x square plus 12x minus 10x minus 8 is equal to 0. 3x common, 5x plus 4 minus 2 common 5x plus 4. So this is 5x plus 4 and 3x minus 2. So x will be minus 4 over 5 and 2 over 3. So cos x will be minus 4 over 5 and cos x will be 2 over 3. So the x will be, we have to write the answer up to 1 decimal place, so that is 48.2 and 216.9, 143.1 and 311.8. So that is the solution of this quadratic equation. So these are the values of x. Question number 10, part 1 is, it's given that fx is equal to e to the power minus 2x and gx is equal to x over x minus 3. Sketch the graph of y is equal to fx, showing the coordinates. So this is fx is equal to e to the power minus 2x. So let's say the graph of e to the power x then e to the power 2x, e to the power x. So e to the power minus 2x will be e to the power minus 2x, and this is the point where it's going to intersect. That is x is equal to 0 and y is equal to 1. The range of gx, where x is greater than 3. So we can see from here that the range is always greater than 1. We have to find the inverse function. So let's say y is equal to x over x minus 3. So y into x minus 3 is equal to x. Xy, we open the bracket, xy minus 3y is equal to x. To find the inverse function, we have to make x as a subject. Here y is a subject, so x, we have to make x as a subject. So we can write that separate x. So this is xy minus x is equal to 3y. X common, y minus 1 is equal to 3y. So x is equal to 3y over y minus 1. Now to make actual g inverse x inverse function, again replace y by x. So it will be 3x over x minus 1. So that's how we find the inverse of a function. And we also mentioned this is x minus 1, so we can say x is greater than 1. Part D is find f gx. So my advice is whenever you find f gx, it's a gx. So gx is x over x minus 3. Write it like this. Now the fx is e to the power minus 2x. Everything will remain there, e to the power minus 2. Where x come, it will become x over x minus 3. Now it's given that it is equal to 3. So e is to the power minus 2x over x minus 3 is equal to 3. Let's take log on both sides. This is ln, this is, so it will be ln, it will be ln 3. So ln 3 will be minus 2x over x minus 3. So we can write it x minus 3 ln 3 is equal to minus 2x x ln 3 minus 3 ln 3 is equal to minus 2x. So it is x ln 3 minus 3 ln 3 is equal to minus 2x. Take x on one side, so minus 3 ln 3 is equal to minus 2x minus x ln 3. So minus common, x plus, not x, let's take minus 2 common. Let's take x common here. So minus 3 ln 3 is equal to, let's take x common, negative x. So it will be 2 minus 2 plus ln 3. This negative and negative is cancelled. So we can say that x is equal to 3 ln 3 over 2 plus ln 3. And that's it. That is the answer of this question. So this is the value of x. The curve she shown in this figure has a parametric equation. It's saying x is equal to 3 cos t and y is equal to 9 sin 2t. And the range of x is, the t is from 0 to 2 pi. So t is 0 to 2 pi. That is the definition of this function. The curve meets the x-axis at a and b. At a, y is equal to 0. So 9 sin 2t is equal to 0.